Hello everyone. This video is going to be really quick because we really discussed this already in chapter 11 when we did arc length and sector area. So we already really did discuss what an arc is, and you were actually able to find the arc length. But we're going back a little bit, and just so that we know the definition of an arc, it's a portion of the circle. So right now in this picture there's an arc AB right here from A to B, or technically we could go A to B. And so that's the two arcs right here. And we're going to discuss, obviously you should know that the red arc is smaller than the blue arc. And without any measurements on there, we can't tell exactly what they are. But what we do need to know in this chapter is specific names of arcs. There's three, and then the last one would be semicircle. Let's start with a semicircle because I'm hoping that you could at least figure out what a semicircle is. A semicircle is an arc whose measure is 180 degrees. If I needed to label those arcs, I know that this is a diameter. That's the only way that I would know it's a semicircle, so it'd have to connect the diameter. Now, any arc bigger than a minor arc always has three letters, and there's a reason for it, because we need to tell, if I just say AC, you don't know if I'm talking about the upper arc or I'm talking about the lower arc. So 99, actually, all the time, they're going to have three letters in it. So, for example, ABC would obviously be the arc above, and then ADC would be the arc below. Didn't matter, CDA is the same arc. You could go back or forth. Let's go back to minor arc. Hopefully you know that minor normally means smaller or less than 18 years old. And then major is older, or major leagues, the big time. So a minor arc is an arc whose measure is less than 180 degrees. The thing you have to remember about minor arcs is that they will always be named by two letters. So examples of arcs in this problem are AB, BC, CD, and DB. So AB is an example, BC is an example, CD, DA, AD. Okay? Major arcs are arcs that are greater than 180, but they're going to be less than 360. And I know that kind of seems weird because we normally only have angles that are between 180 degrees, but you saw when we did arc length that we had to use values like 256. If I need to specifically name those types of arcs, then we're going to say something like AB and then all the way to D. You don't need to use four letters. I don't need to say A, B, C, D, because if I know I go from A to B, I know I'm going to go all the way around to D. There is no cutting through a circle. So it's not A, B, slice right down to D. It goes around the circle. And then another one could be B to C all the way to A. So BCA. There's more. A, D, all the way back to B is an arc, or B, A, and then to C. So that's what we have to know. You already know what an arc is. It's a part of a circle. You have to know there's minor, major, and semicircles. The second thing we have to do, which you already kind of basically know, since we did arc length first, is that the central angle, which means the vertex of an angle. So here's an angle. This angle is created by two radii, and the vertex of this angle is at the center of the circle. If it is at the center of the circle, then the arc that it intercepts is equal. So to finish, it's a central angle is equal in measure to the arc that it intercepts. And when I say intercepts, it means that if I extended these radii, for example, if I took a ray for an example and just extended this ray out here and extended this ray out here, intercept would be what's between the two rays. So that's the arc it intercepts. I kind of say, I think, keep it in your brain. Central angle is the same. So if it's in the center, it's going to be the same as the arc. So I'd like you to take a second. You should be able to do this on your own at this point, but I'll give you the answers in a second. So first thing you need to do is say whether it's a major, minor, or a semicircle. And then once you decide that, you need to find the measure of the arc. So probably be best if you pause the video, try this on your own. Okay, hopefully you paused it and came back to this. TQ, first of all, the biggest hint for you would be how many letters is this? TQ is 2 letters, which automatically means it's a minor arc. There's no if, and, or but. So if it's a minor arc, it's got to be less than 180. From T to Q goes to 120 degrees. QS, when I come, or I'm sorry, let's do QRT. It doesn't really matter. But if I do Q to R all the way to T, I need this. So it comes to my first thing. How am I going to find what this degrees is? Hopefully you realize that if an entire circle has to be 360 degrees, then all of these must add up. Well, in that case, what's missing is 100 degrees. So if I wanted to find QRT, from Q to R is 60, R to T is 180. So 180 plus 60 is 240. I'm sorry, 240. Okay, if I did T, Q, R, well then I know from T to Q is 120, Q to R is 60, that's 180 degrees. That's a semicircle, and that's 180. I'm just going to go right down here because if you look at RST, it actually just goes underneath, and it's 180 degrees as well. So it is also a semicircle. There we go. Okay. If you did TS, TS is 80 degrees. It only has 2 letters, so that's 2 ways we know. I'm not sure where the box is. There it is. Okay. And so it is a minor arc, and it's 80 degrees. QS, Q to R is 60, R to S is 160. And I know that kind of seems big, but please remember, it's 2 letters. That means it's a minor arc, and it's 160 degrees. Our last problem is this. If we look at this, it's no harder than the problem before. So all you need to do, if you have to remember, what do these things mean? Congruent. So it means that those 3 are congruent. And the thing is, when you come to circles and there's not all the values, you need to try to label, try to identify diameters or semicircles. So in this case, if I just put this here, you'll see that that's the diameter because it goes through the center and it connects on both sides of the circle. That was in the vocab from the day before. So that's a diameter. Anything under this diameter is 180. Anything above this diameter is 180. So the way I would start is I know that this must be 180. So I take 180, I minus 104, it equals 76. But that's not, now I know that both of these together have to equal 76, so I divide, and this is 38 degrees. If that's 38 degrees, this is 38 degrees, and because this is ticked mark, this is 38 degrees. So that leaves me with Y is 38 degrees. I know that Z, since it's a central angle and it goes to arc AB, is 38 degrees. And the only other thing left to find is X, and there's a couple ways to do it. I could say, okay, the entire circle is 360. So I need to take 360 minus all of these. Or I could just say this upper half has to be 180. And I know that this is 38 already. So I'm going to subtract 180 minus, and I get that this is 142 degrees. Okay, you can just close this video, and then you can keep the laptop on. And then I just like you to flip over the note sheet and work on 1 through 24. You can talk to each other quietly if other people are done. If not, wait till everyone's finished. All right, thanks.